our first stop on this whole idea of reusability and the benefits of using views, functions, stored procedures, triggers, and all the other reusable programmatic objects is to talk about execution plans. Execution plans tie very nicely in with the previous video where we talked about what the 4 steps were, because an execution plan is an instance of a compiled plan. We're actually able to see how SQL Server is going to use the plan. We can see the steps that SQL Server will go through to satisfy our query. Now, I will go ahead and lead with this. Again, 2 things. One, Chapter 11, all about performance tuning. We're going to break down execution plans, compiled plans in much more detail. So I'm really just trying to give you the basics here. And 2, I'm giving you some of this information early without us having talked too much about what these things mean. We're about to see a lot of things about indexes, missing indexes. You need a non-clustered index, or you need a clustered index, or we'll get rid of this sort operator. And we haven't talked about all of those. That's what Chapter 5 is about. So we're going to revisit these ideas when we get to Chapter 5 and talk about how to alleviate some of these problems. And so stick with me. Don't just use this in the spirit that it's intended. Let me show you the basics. Okay, play around with it, but don't get hung up if you don't understand every little piece of it. Okay, now I will reuse the query that we had from our last video. And this was the one where we were looking for all of the addresses that had a city of Paris. And I'll go ahead and I'll change, well, I won't. I'll do this first. We'll execute it. We don't have to pay the penalty of creating a plan because the first person that ran the query created the plan. They paid the penalty. So we're just able to reuse that plan. So when we look at this data, how can we tell what SQL Server stepped through to go to it? How can we tell, for example, whether it joined state, province to country, region first, and then joined those results to person.address, or it joined person.address to state, province first, and joined those results to person.country, region? We can look at the execution plan. The execution plan tells us how SQL Server solved the problem. Okay, so a couple of different ways we can do this. The simple way would be to come up here and go to the query window and tell it we want to talk about the execution plan. And we get 2 choices down here. We can display the estimated, or we can include the actual. Now the difference between these 2 here, let me just sort of freeze the screen here. The top one does not run the query. This is awfully helpful when you've got a query that you know is a 20-minute query, or a very, very expensive query that you can't run in the middle of the day because it just bogs everything down. It does not run the query. It just shows you the plan. And if there is no plan, then you're going to pay the penalty. It's going to have to create the plan and then estimate what the plan is going to be. But it is an estimate. Most of the time, not all, the estimated plan and the actual plan are the same, particularly if you have queries that have already executed. There are going to be infrequent cases where the estimated plan differs from the actual plan, and we're going to talk in Chapter 5 about how we need to make sure our our index statistics are up to date. That's usually when you can find those being different. So don't worry about those. For the time being, the main difference I want you to consider between these 2, this one does not run your query. This one runs your query and then returns also in another tab what the execution plan was. Now there's a little button right here that you can use. This is the estimated execution plan, and then there's your include actual. So I often just will hit Control L. This is how I will do it, because if you look right here, Control L is the key combination that is tied to the estimated execution plan. So let me go ahead and do that. I can hit this, any one of them are the same. Now this is taking a little bit longer the very first time because I've never on this computer, since I've booted it up and launched Management Studio, never launched the execution plans. Okay? Now the next time you watch this, I'm going to just copy this code, close out of Management Studio, launch it again, use the database, paste my code in, AdventureWorks, hit this again. Look how much faster it is to load up. It has to JIT, J-I-T, just-in-time compilation. Right? These are .NET based applications, so it takes a little while the first time you do it, but hey, it's compiled code, so the next time you run it, it's faster. And you pay the penalty the first time. That's a theme. So anyhow, coming back up here, let's talk about what we see. Let me give us this from top to bottom. We'll read everything in here. Did it run the query? No. Notice that it does not have a results pane. It did not run the query. Had we chosen up here to include the actual execution plan, we have to actually run the query and we get a new tab that shows what the execution plan was. Okay? See, that's the difference. Okay? So I'm going to uncheck that box and then I just tell it to display the actual, and it does not run the query. Now let's read this up here, starting up here. In this batch, stop that, there is one query. That means that this query, when we look at it, I don't know why it's doing that, for all of the batch, it takes up 100% of the cost. Cost is a very, very important metric in SQL Server. How does SQL Server know which index to choose? It's a cost-based system. It assigns a value based on how long it thinks something is going to take and how many resources that something will consume. Okay? Whichever has the lowest cost, that's the one it's going to use for the plan. Okay? So this query, there's only one query, so the whole of the batch consumes it 100%. Then it simply puts the query in here. Sorry that it's doing that. Now we see that right here we've got a missing index. We're going to have to see this in chapter 5, and it's giving us the sort of a shell of the code that it thinks would fix our query and make it 72% faster. Whew, it's pretty big. Don't know if we should do it though. We need to analyze a little bit more and learn more about chapter 5 before we will talk about that. Now the how SQL Server has done this is in this graphical plan. This is called the graphical plan, the graphical execution plan. It reads from right to left. Sorry, meant to do it like this. Right? This, when things are stacked on top of each other, that means they happen simultaneously. Okay? These two work together, and it takes these two tables, address and state province, and it performs the join. You can see the join being done. While it's performing the join, it goes and it grabs the country region table and it joins country region to the results of address and state province. So you typed in your code saying that you wanted to join address to state province and then join those results to person.country region. Just so happens that your plan does it the exact same way. Now, before we dig into, you obviously saw a flyout right there. Before we get into what these flyouts are, we're about to hear in just a second, I want to show you the effects of flipping it around. What if I did this a different way? What if I said from person, state, province, join country region, and I put join person.address right here? This is the same code. Right? I'll go ahead and tell you. I don't know how much you know about SQL. If you don't know your joins, then this is probably a little bit confusing for you. But these are the same query in terms of the result sets. These are inner joins. We're dealing with the intersection of these tables. Okay? Because they are inner join, I can flip the tables around as long as I'm able to logically join them. And here we're using a parent-child relationship, foreign key, primary key relationship here. Okay? So I can flip these around. These queries logically and physically return the exact same data. There's no difference for these queries in the data that the user sees. The only difference is in how I wrote the join. Okay? But what does SQL see? Will it generate two execution plans, two different execution plans? Okay. When we look at it, now that we have two queries in the same batch, we hit Control L. You can now see that here's the query cost of the first query, here's the query cost of the second query. And we can use this, stop that, we can use this to tell which of these queries is faster. Well, neither of them are faster. They both take up 50% of the time. They're equal. Now, it may be that they are equal in query cost, but not equal in the plan. So let's look. Okay, we're joining address to state province, joining that to country region in the top query. What about the bottom query? Address to state province, joining that to, it did not matter to SQL Server the order that we put these in. It determined through a cost-based system that the most efficient way to join these three tables together was to do this, to join them state province to address first, use that to weed out all of the rows we don't need, and then join that to the country region. Now, it's also smart enough to tell us that there's a missing index. The missing index, you can see it's going to opt to, it's telling us we should have a non-clustered index here to support this. It could change these all around once we add that in. We'll have to see more of that in Chapter 5. But this is your execution plan. You can see what it's happening. Okay? Reads right to left. Now, we can see the cost of this query. Okay? I want to show you this. How about now, for the second query, I add in an order by. So let's now order this by CR.country region code. Maybe we want to see Paris, France first, and then followed by Paris, Texas, USA. Okay. How will this affect it? We've only changed one of the queries, though. Let's look at our execution plan up here. Ooh, do you see now we do have a difference? This query is more efficient. This query takes longer, right? Meaning it takes up 51% of the time to run both queries to run query number 2. And we can see this if we look at the graphical plan now. Notice that the last member here of our graphical plan is the hash match inner join with a cost of 12%. What this 12% says is, okay, this whole query costs 100% of itself. In other words, if you added up 71% plus 2% plus 14 plus 1 plus 12, that's going to equal 100%. Okay. Down here, though, notice we have a new operator. That's what these are called. This is an operator. This is a sort operator. Okay. It's not 71% like it was down here. This is now only 67% because we have to include the cost of the sort operator. This is the same plan, but we've added in a new sort operator. Okay, so that's your cost-based metrics here at work. And we can see that this one is more expensive. Now, this is almost like anecdotal evidence here, 49% to 51%. Let's actually put some numbers on that. If you all go to the far left operator here, the select, this tells you the total amount, the cost. Okay? You can see here that the cost. Let me just read here about what we have. We're using a cached plan. The size of that cached plan is 64 bytes. The operator cost, that's me. I'm the operator. Okay? How much do I cost to run? 0. The select is really the byproduct of all of the previous operators. Okay? It is the operation, if you will. Okay? How about the subtree? The subtree cost is everything that has occurred before me and me together. Okay? So how much did all of us together cost? Like if we look over here at the subtree cost of the hash match inner join right here, it's this. It's me plus everything that led up to me. Okay. So the subtree cost is 0.25579, very precise. What? What does that represent? Seconds. Okay. Now this is one of those areas where it's a little tricky. We're going to revisit this in much more detail in Chapter 11 when we talk about performance tuning, but for the time being, here's what I want you to understand. When they were designing SQL 2005, 2008, 2008 R2, they had a bunch of labs. These labs had modern hardware, and they would run all kinds of tests using, hey, similar queries to what you have here. They obviously have very, very finely tuned tests and lots of databases that they ran these against. And they used all of this data to come up with estimations. And their estimations said that, hey, when we're dealing with about 316 rows, and we're dealing with a cache plan size of about 64 bytes, and when you start looking over here, you can see at the individual operators, and we're dealing with 398 rows here with each row size only about 36 bytes. Here's the cost, and now we're whittling it down to where we're only returning 324 of those rows. When it gets over here and looks at that, it says, you know what? In our test lab, a query like this would take about 0.25579 seconds to execute. Now that does not mean on your hardware it's going to take 0.25579. Your hardware is almost inevitably going to exceed whatever these estimates are. Not always, but most of the time. Okay? Now, looking at this, let's look at an individual one here. Let's take a look at this particular operator here. We're dealing with a clustered index scan. You can see that it's using a clustered index scan, which we'll learn about a little more in Chapter 5. The I/O cost, how long is it going to spend on disk operations? Negligible amount, 0.03. How about at the CPU? Another negligible amount. How many times will this execute? Just once. We'll see examples later on when we will loop through things. You might see nested loops if you've ever seen those. Operator cost. How much do I cost? I cost 0.004. I cost I/O plus CPU times the number of times I execute. It's just simple math. So this plus this times this equals my cost. Now, if we go down here to the address index scan, we're doing a non-clustered index here. So 0.15 plus 0.02 times 1 is 0.18. There's a little bit of arithmetic rounding up here as well. Now the subtree cost is me plus everything that's occurred before me. Well, nothing has occurred before me. I'm the first operator in this thread. When we come over here to hash match is 0, no I/O cost, a little bit of CPU cost, I only iterate once. So I cost 0.03. But me plus these other two guys over here, me plus everything before me, we cost together 0.22, 0.220. So when we look at this cost up here of 0.255, you and I know that it's right in here where the bulk of the work is being done. And in fact, we could see that it's really here. 71% of the overall cost of the query is being taken up right there. Okay. Now, the last thing I want to show you, again, I'm just giving you the basics, right? Last thing I want to show you, you can see these in other ways. I can right-click over here, and I can tell it to save this. So I can save this execution plan, and it will save it in a SQL plan. And then I can load it up, and I can share that with my other developers, or we can save that for historical reasons. I can also ask it to show me the execution plan in an XML format. Now, this is probably not something where you want to use, but this is a great way to share this with other people, and it's also a great way that programs can take advantage of your execution plans. You can feed this information to performance tuning programs, for example, and they can say, oh my gosh, you have a query that costs 0.25, oh my God. Okay. All right, enough about this. The show plan, in case you wanted to programmatically do that, one of the things you can do is say, I want to do show plan. And there's a couple of different show plans. We can do show plan all. And I set that on. And so when I run this query now, it shows me the execution plan in a result set format. and so I can see the operations. You can see. You could just kind of use that to say, hey, I want to see the rows and things like that. So SHOWPLAN, and then you have your SHOWPLAN XML that you could turn on instead of that. And I'd have to set my SHOWPLAN all off, because if I turn SHOWPLAN on, then it won't run the query. It will just show me what the query's execution plan would be. And so now SHOWPLAN XML on, when I run this, then it generates an XML SHOWPLAN. Okay? And you can see it there. And it looks like they have not changed the, oh golly, ugly. It looks like they have not changed their alias from SQL Server 2005 XML SHOWPLAN. But you can see when we click on that, it loads up the graphical plan. That's that SQL plan.